Okay, so we've got equation here about a small box of mass 15 kilograms. Diagram here. There's a total of 9 marks this question, so it's quite involved. And coefficient of friction, so there's going to be friction involved. That means the plane must be rough. And there's a force P acting at an angle of 50 degrees. So find the value of P giving us two significant figures. Key point here, boxes on the point of sliding along the plane. That means that friction must be its maximum value because of that. So this information here tells us that friction is equal to the maximum value because it's just about to move, which is actually equal to mu r, where mu is the coefficient of friction, given that here is 0.2, and r is the reaction force. So let's get our diagram drawn correctly. So, well, mass in this question means there's a weight acting vertically downwards. As it's sitting on the plane, which that would stop happening, there's a reaction force acting straight up. If the force P is acting to the right, that's the way the box wants to be moving, or is about to move, so friction must be acting in the opposite direction. Okay? So, we've got reaction force here, 15 G, which G is 9.8, not grams, G due to gravity, and then we've got friction acting to the left. So then the only force we've really got that's annoying is we've got this force P that's annoying, so we're going to break that force P. It's not acting horizontally or vertically. Let's break it into its horizontal and vertical components. So let's just put all that together, and then let's analyze this one force, the one that's not acting the way we want it. Let's analyze that. So that's P, right angle, 50 degrees. We can break into components. We should be quite good at this now. So the opposite side is the sine, soft from SOHCAHTOA. P sine 50 degrees. And down here we've got P cosine 50 degrees. And then that allows us to get our two equations. So that's the first bit, and these are worth quite a lot of marks to get these two bits. And we might have to do solving on the next page. We won't have enough room on this page. So let's get these two equations down first. Let's resolve horizontally. And then what was acting to the right? Well, the horizontal component of P is acting horizontally to the right. So that's P cosine 50. And friction is acting to the left minus FR. So friction is equal to 0, so the box isn't moving or not being caused to move. Let's resolve vertically and get these two equations going. So what have we got acting up? We've got R acting up. We've also got vertical component P, so that's plus P sine 50, and acting down we've got the weight, so minus 15G. Again, that must be equal to 0, which is equation 2. So I'm not sure I'm going to have enough time to solve that, so I'll add this to the second part of the video. But we just analyse it quickly first. Well, first of all, we can get we should notice that this really becomes, it's worth a mark this, from what we said about here about F friction being mu r, we can rewrite this equation. So P cos 50 minus mu r is equal to 0. Okay, so really 1 becomes that. We can see we've got two unknowns because we actually know what mu is. It's 0.2. We've got a P and an R in this first equation, and we've got an R and P in the second equation. So it's going to take a little bit of solving in order to get this right, and there's a couple of methods to do this. So we'll have a look at that in the next part of the video.